Welcome to homework.
Chapter 16, Problem 62 from the book Chemistry, the Central Science. The question states that active ingredient in aspirin is acetylsalicylic acid, a monoprotic acid with a Ka of 3.3 times 10 to the negative fourth at 25 degrees Celsius. What is the pH of a solution when dissolving 2 extra strength aspirin tablets containing 50 milligrams of acetyl acid each in 250 milliliters of water? So the first thing we had to do is find the amount of moles of acetylic acid in the tablets. So first, to do that, we had to add up the total amount of acetylic acid in each tablet, which is just going to be 2 times 500 milligrams. So that just is equal to 1,000 milligrams. Then we had to convert milligrams to grams, and there are 1,000 milligrams in 1 gram. And so when we do that, we then just have 1 gram of our HC9H7O4. So now that we know we have 1 gram, now we have to convert that 1 gram into moles. And now, since we do that, we are going to have to find the molecular weight of our acid. And to do that, we just have to add up our molecular weight for each atom in the compound and multiply by how many there are. So we have 8 hydrogens plus 9 carbons plus 4 oxygens. And when we add all of that up, we get 180.7 grams per mole. Now that we know the molecular weight, we can find how many moles we have by taking 1 gram divided by the molecular weight. And we will get 0.00556 moles of our acid. Now, to find our molarity is equal to our moles over liters. And we already know our moles, and we know our starting liters is 250. And to convert 250 milliliters to liters, you just divide by 1,000. So it's 1,000 milliliters in 1 liter. So we have 0.25 liters of solution. So then we have 0.00556 divided by 0.250. And we have a starting solution of 1.387 times 10 to the third molarity. Now, since we have the starting concentration of our acid, we can now plug that into our ice table to find what the final H ion concentration is. So to write this equation out, we have the HC9H7O4 goes to HC9H7, sorry guys, H plus C9H7O4 minus And our starting concentration is 1.387 times 10 to the negative 3. And we have 0 of those other starting reagents. And then we subtract a unknown amount, and we add that same amount to the other side. And then we just add those two columns up in our ice table to find the equilibrium concentration. And so now we just plug it into our Ka equation. So we have Ka is equal to our products over reactants, which is our H plus, times our C9H7O4 minus over our HC9H7O4 concentration. And we have a Ka value of 3.3 times 10 to the negative 4. And so we just plug those numbers in to solve for x. So we have 3.3 times 10 to the negative 4 x squared all over 1.387 times 10 to the negative 3 minus x. You plug this into your solver function on your calculator, and you can solve for x. And we get the value of x to be 0.0000 531, and that is our concentration of our H plus ion, which is right here. So X is equal to our H plus concentration, which was 0.000531. And the question was asking us for the pH. So to find our pH, we just do the negative log of our H plus concentration. And so when we plug that into our calculator, we get our pH value of 3.27.